Okay, so I want to connect a couple more concepts that have to do with parametric equations. And so one of the things that you need to know is that we could ask you about these things called vectors. So far, we already know. Let's just kind of do a really quick review. We have an x position, we have a y position, and we've already talked about the fact that dy dx is dy dt over dx dt, okay? And we've also already learned the second derivative equation as d dt over dy dx divided by dx dt. Don't forget those. So we already know these, okay? Now, you need to know that for the purposes of just kind of definition of things, when I refer to x prime of t, I'm really talking about dx dt, which is a rate at which the x coordinate is changing. And when I talk about y prime of t, I mean dy with respect to t, and that's the rate at which the y coordinate is changing. Now, I'm going to introduce to you something called a vector. And vector is just two things with arrows on the end of it separated by a comma, okay? And vector notation x comma y is just the position vector. So when you see a vector written x of t, y of t, we call that the position vector. And when you see x prime of t and y prime of t, we call that the velocity vector. And when you have a vector composed of these second derivatives, that is the acceleration vector. It's just a way of representing information just with parentheses, these two little funky arrow bracket things, okay? Also, for the purposes of just kind of having it out there, when we're talking about dy dx, it's the rate of change of y with respect to x, which you know is the slope of the tangent line, which is the slope of the tangent line to this curve, the curve that your particle is following. And when we reference the second derivative, that's your rate of change of the slope. So this isn't anything new. This is just kind of referencing stuff you already know. So let's get to the new stuff. Speed. You're going to be asked on the AP exam about the speed of a particle. Speed and the word magnitude mean the same thing, okay? The magnitude of the velocity or the speed. You need to know that they're going to say both of those words. They might say to you, find the speed of the particle. They might also ask you to find the magnitude of the velocity vector. So I'm going to introduce a new equation to you. Speed is the absolute value of the velocity vector, okay? But the velocity vector has two components. So speed is the square root of dx dt squared plus dy dt squared. And guys, this sure looks really similar to the arc length equation, S arc length, but the only difference is arc length has dx dt squared plus dy dt squared under a square root, and it has an integral. So you need to make sure you know these two formulas are completely different, speed and arc length. So you're going to be asked about arc length or distance traveled of the particle. You might be asked for the speed of the particle, and those are two different equations, okay? So let's go through a couple of examples. Example number 1, I have x of t and y of t, so I have the position, and the first thing it asks me to do is to find the velocity vector. Well, we know that velocity is x prime of t and y prime of t. So if I take the derivative of my x, my position, I get 6t squared minus 10t. And if I take the derivative of the y component, I get 8t cubed plus 3t squared. It then asks me to find it at t equals 1, so notationally, v of 1 is equal to 6 times 1 squared minus 10 times 1, comma, 8 times 1 cubed plus 3 times 1 squared. And we're going to plug those in, and we should get about negative 4, comma 11. So this is your velocity vector at t equals 1. It then asks me to find the acceleration vector. So a of t is now going to be represented in vector format. Remember that that is x double prime of t and y double prime of t. So if I take the derivative again, I get 12t minus 10 and 24t squared plus 6t. And if I find the acceleration vector at 1 and plug in 1, 12 times 1 minus 10, comma, 24, 1 squared plus 6 times 1, and I should get 2, comma 30. And so those are the acceleration vectors for my particle, okay? Now, this word magnitude is the same thing as length. Those are equivalent expressions. Now, when we talk about position of a particle at a certain point has two components. It is composed of an x length and a y length. So if you're ever asked to find the magnitude or length of the position vector, I'm going to use the Pythagorean formula, and it's going to be the x squared plus the y of t squared. And this comes from the Pythagorean formula. Okay? What if you're asked to find the length of the velocity vector or the magnitude of the velocity vector? So here I have my velocity vector, and it has a component that is, x prime of t, and it has a y prime of t component because it is made up of those two pieces. So if you're asked to find the magnitude of the velocity vector, I'm going to use the Pythagorean formula and find x prime of t and square it and y prime of t and square it. But this is probably the most important one because what you've just done here is this is also the speed of your object. So this equation is super important. They might ask you to find the magnitude or length of the acceleration vector, and he has two components as well. He has x double prime of t component and a y double prime of t component. So if you're asked to find the magnitude of the acceleration vector, it's x double prime of t all squared, again from the Pythagorean formula, and y double prime of t squared. But the one that they're going to ask you the most about has to do with speed or magnitude of the velocity. Okay, so what is a question going to look like? A particle moves in the xy plane for time greater than 0. I give you the position of the particle, x of t and y of t. Find the magnitude of the velocity vector when t equals 3. Okay? So we're going to start by finding the velocity vector. If I take the derivative of my x component, I get 2t plus 5. And if I take the derivative of my y component, 1 over stuff times the derivative of stuff. Now it has asked me to find the magnitude of the velocity vector at t equals 3, but you should probably start by just finding the velocity vector. So if I plug in 3 at t equals 3, 2 times 3 plus 5, and 2 times 3 over 3 squared plus 4 is going to give me the velocity vector of 11 and 6/13. So using my speed equation, remember that speed is the same thing as the magnitude of the velocity vector. My equation says it's supposed to be x prime of t squared plus y prime of t squared. And again, don't confuse this with arc length. All you're going to do is take the 11 and square it, and the 6/13 and square it, and we get the square root of 121 plus 36 over 169, or 11.01. Okay? Almost done, guys. I really like this next equation because I think it is pretty straightforward. It says I have position x of t and I have position y of t, and they've given you restrictions on t, and it tells you that the path of the particle intersects the x-axis twice. Write an expression that represents the distance traveled. Now, you're going to read distance traveled and you're going to start thinking, oh my gosh, total distance, absolute value of the velocity, integral. But distance traveled in parametric is talking about arc length. And it says between the two x-intercepts. So first off, if you want to find the x-intercepts, we got to have a whole bunch of information. We are going to need our limits of integration. So when it says x-intercepts, that's implying that y equals 0. So I'm going to take my 1 minus 2 sine of t, and I'm going to set it equal to 0. So I get 1/2 is equal to sine of t, and that happens at t equals pi 6 and 5 pi 6, and both of those happen to be in between 0 and 2 pi. So that's nice because I can get my distance traveled by my arc length formula. And the arc length formula is the distance from A to B, square root x prime of t squared and y prime of t squared, dt. And I think when we wrote it down, we actually wrote them as dx dt's and dy dt's, but remember that those are the same thing. So we're going to have an integral from pi 6 to 5 pi 6, square root. I'm going to need to find x prime of t and y prime of t, so let's go ahead and find those. X prime of t is going to give me -4 times negative sine of t, or just 4 sine t. And y prime of t is going to be -2 cosine t. So we're going to plug both of those in. 4 sine of t all squared plus -2 cosine t all squared, and don't forget your dt on the end of it. Notice it said do not evaluate, so that's all they were looking for in this question. Okay? We learned earlier in the year that a particle moving along a line is at rest when its velocity is 0. If the particle is moving along a curve, meaning both x and y, then the particle is at rest when both positions equal 0. So this is important because this next question says, I'm going to give you a position function, I'm going to give you a position function, and I want to know when the particle is at rest. So you need to know that your velocity vector must both be 0, 0. Okay? So let's start by finding that velocity vector. We need to find x prime of t. So 6t squared minus 30t plus 36. And I'm going to set it equal to 0 by factoring out a t. So I get t minus 6 and t plus 1. So t equals 6 and t equals -1. And I'm going to do the same thing with my y prime. We're going to find y prime of t. So 3t squared minus 6t. We're going to set it equal to 0. And I get, by taking out a 3, t squared minus 2t. And if I take out a t, I get t minus 2. That means that t equals 0. And I just realized I factored this one up here wrong, guys. Oh dear, I don't want to have to remake the whole video, so just bear with me. This should have been t minus 2 and t minus 3. That's what happens when Miss Lowry tries to make videos really fast. Oh dear. So now we get t equals 0 and t equals 2. Now this is super, 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 super important. I don't care about this guy, and I don't care about this guy, because only one of the components is 0. In order for this particle to be at rest, both the x and the y have to be a shared value. So that means at t equals 2, both x and y are at rest, and that means t equals 2 produces the velocity vector of 0, 0. So you have to share that point. Okay? Last question of all the notes for forever and forever, amen. I'm giving you a velocity vector, and I want you to find the position. Now, it gives you position of 7, negative 4. Guys, that is your x, that is x of 0, comma, y of 0. And I want to find the position at t equals 1. So we're going to actually do this using first FTC. If I have t equals 0 and I want t equals 1, we're going to take the integral to find x of t. Let me back up. We're going to take an integral from 0 to 1 of my velocity vector, which is x prime of t dt. And because of first FTC, that will equal x of 1 minus x of 0. Are you with me so far? Okay. I'm going to set up my integral from 0 to 1. We know that x prime of t is 3t squared minus 4t dt. We want to find the position at 1. We were given the position at x of 0 is 7. So now we're going to take the antiderivative of this guy and get t cubed minus 4t squared over 2, evaluated from 0 to 1. When I plug in 1, I get 1 cubed minus 2 times 1 squared minus 0. And I can find that x of 1 minus 2 is negative 1, plus 7 is 6. And I've done this in one step using first FTC. Don't underestimate the fact that you can use first FTC and set up a definite integral here. If you have one position and you're looking for another, set up your integral as a definite integral. We're going to do the same thing from 0 to 1 with our y prime of t, which we were given. And that's going to be equal to y of 1 minus y of 0. I'm going to fill in 8t cubed plus 5 dt. We're looking for the position at 1. We have y of 0 is negative 4. So now we're going to take this antiderivative, 8t to the 4th divided by 4, plus 5t, evaluated from 0 to 1. Y of 1, that becomes plus 4. If I substitute in, I'm going to get 2, 1 to the 4th, plus 5 times 1 minus 0, 2 plus 5, y of 1 plus 4. If I solve for y of 1, 7 minus 4 should be 3. And now you have found the position of the particle at t equals 1. Good way to kind of write that is that the position at t equals 1 is 6, 3. And you write it as a position vector. Okay? There is an F or Q on this page. I'm not going to walk all the way through it, but I would encourage you to try this F or Q all by yourself. This is a really good example of all the things that you could be asked to do. You're going to be asked to write an equation of a tangent line, find the speed. When does the tangent line have a slope of 4? Find the position of the particle at 1. I think it's a really good, nice full F or Q that has all of the things you could be asked to do.